Okay, let's go. I believe I stopped here the last time. I believe this is where I stopped the last time. Okay, so I'm going to where did I stop? Question 2.5 around there. Can huh? Yes, okay, so let's continue from here. Today the target is to try to finish up to part 2 lah, the entire part 2. Okay, huh? Yeah, for topic 2. Hold on first. Okay, yeah. You should be getting back some of your practice sets. Maybe you open the window, but at the end of the day, do remember to close your window. The bee season is back. Yeah, so a few GH2, GH1, they got stung by bees. Okay. Yeah. Okay, are you ready? Okay, maybe I write down answer. This one no name. This one looks like it belongs to, who belongs to this? May I ask? I know it's from 407. Javier. Yeah. Sounds like Javier. The handwriting and the beautiful working. So much steps and details, so meticulously done. Okay. Which one? Okay. What do you say? What? Okay, can I? Okay, let's go on. Question 2.6. Okay, question 2.6. Applying the double angle. Still remember the double angle? You all still remember? Need me to write on the board? Need me to recap? Maybe I recap now. Just in case. Okay, so we all know that the last time round in question 2.4, when we talk about the, okay, first we went through, let me just write on the board. Let me just write on the board. Okay, so we talk about the addition angle formula. Okay, addition angle formula. Right? Sine, remember sine is a good boy. Sine always brings the cosine along. Sine A will bring along cosine B. Plus minus. So sine is a embraced diversity. You embrace cosine, you embrace angle B. Someone that's different. Sine also takes plus and preserves the operator sine minus cos A sine. Okay. Cosine is a naughty boy. Cosine will always run to the canteen first. He will not wait for his friend. He doesn't pay attention to the teacher in class. He takes the plus, you write minus. Okay? And sine will be the poor guy then. Tangent is a little unstable. Sometimes it's a good boy. Sometimes it's a naughty boy. Okay? So tangent is a good boy, the numerator. Because tangent is sine over cosine out. Okay, then 1 minus plus tangent A, tangent B. Okay, so just to recap, in topic 3, this is what we covered the last time. So for topic 3, how do we get to the double angle? The double angle is very simple. So you just need to apply. You will see that sine 2A, if you apply the addition angle formula, sine 2A, I can see as sine A plus A, right? So it's like sine A plus A, sine A cos B, cos A sine B, right? But if I change the B to A, right, you can see that it becomes cosine A cos B. Okay, can I? Now cos 2A is cos square minus sine square. Okay, cos square minus sine square. Now if you replace the cos square as 1 minus sine square, to replace the cos square as 1 minus sine square, eventually you get 1 minus 2 sine square. If you replace the sine square with 1 minus cos square, you get 2 cos square A minus 1. Okay, you see how it is? How you are money. I have a lot of that at home. You know, I also have a lot of renminbi, but one suitcase. No, just kidding. Okay, can I? So with that, you have you actually have 3 versions for cos 2A. So sometimes when you're doing proving, you need to use different versions. Okay, you need to use the different situation calls for different versions of cos 2A. Right? Just like when you go out with different people, maybe you wear different dresses, different makeup. Okay? Can I? Tangent 2A is 2 tangent A, 1 minus tangent square. In question 2.4, we have done the proving. We have done the proving. I hope you are done. Okay. Maybe I just do a quick check. Who has done? Okay. Who has done up to 2? Okay. Who has not done 2.4? Not the run, the question. Haven't yet. Okay. Okay. Who has not done 2.3? Who has not done 2.5? Up to 2.5. Who has not done 2.6? Okay. Okay. I'm around there. Okay. Can. Okay. Got you. Got you. I write the answers on the board. Okay. Let's continue. It's not your fault because we lost a lot of lessons. Question 2.5. Question 2.6. After past one. Jerry, where are you at now? 2.5. Okay. What today? Where's Jun Kai? Oh. Anyone else in Malaysia? No one. Anyone not in class, please raise your hand. Yeah, everyone. Question 2. Okay, question 2 is just show. Question 2.9 is just show. That part 3. Part 3, I think I won. Anyone on part 3? Question 3. Check your answers. Check. Question 3. Question 3.1 is also a show. Question 3.2, maybe I showed it. Okay, so let's take some time to try the question. Let's aim up to finish up to 2.9 today. Okay, if you are faster than 2.9, you can do the practice set. If you do not know where to find the practice set, it's inside your Google Classroom, WhatsApp chat, or I can airdrop you. And the question, you don't have to listen to me now. Okay, so I go through 2.7a. Now, there are some numbers that you must fall in love with. Those numbers are like special angles, 45, 30, and 60. Right now. So when you come to me and you say 22.5, hey, isn't that like half of 45? Right? Isn't that half of 45? So those are some numbers that you sort of, in a very good way, you got to memorize it. Okay, so what I'm doing is 2.7a. I'm thinking of this. Cos 2a. I'm thinking of cos 2a to be 2 cos square a minus 1. All right. So can I say that if I have cosine 45, this is the same as 2 cos square 22.5 degree minus 1. So when I solve 22.5, the friend that came to my head is the 45. Because 45 is special angle. So cosine 45 is done plus 1. Divide by 2, I will have cosine square 22.5. Cosine 45, remember, is left hand side over right hand side. Square root 2 over 2. Plus 1 over 2. This is the same as, if I were to multiply by 2 over 2, that gives me square root 2 plus 2 over 4. So this is 2.78. Got it? That's my answer. Can hold. So next, I go to, I get that. Or if you got iPad, you go to my, yeah. You go to YouTube, you go and search 404 lesson 19. I went through yesterday. Just nice. Okay. If you want to on just, okay, so now, you off the ball. Okay, so now, sine square, right? Sine square, 15 degree. Again, what comes to my mind? The friend is 30. sine 30. So sine 30, and I know that cos 2a is 1 minus 2 sine square a. So that means cosine 30 is 1 minus 2 sine square 15 degrees. Okay, learn to put numbers into your letters. This means that if I were to maneuver around, sine square 15 is basically just 1 minus cos 30 divided by 2. What is 1 minus cos 30? Cos 30 is 1 over square root 3. 1 over square root 3 divided by 2. Right? You can put this as square root 3 over 3 also. Multiply by 3 over 3. The answer is just 3 minus square root 3 over 6. Do I get that? Hey, am I wrong? What's cosine 30 again? Or square root 3 over 1? Silly me. So I have square root 3. Okay? Yeah. Square root 3 over 2. Sorry, over 2. Over 2. So therefore, this is the same as 2 minus square root 3 over 4. Okay? Can I? Now, I believe anyone stuck at 2.7c. 2.7c is going to be quite troubling for some of you, am I right? So let me share with you how I do it. Very easy. Once I show you, it's like a trailer that spoil the fun already. Okay, maybe for can I just tell you, think of this first. Put the first and third term together. And after that, put these two terms together. The second. So, okay, in case I bother you, Ethan, both Ethans actually. Blue, put one side. Brown, put another side. So I'm going to write it this way. Tangent square 15 minus 1 over 1 minus tangent square 15 degree, 2.7c. Okay, for recording purposes, I will go a bit more detail. So can you see that the both Ethans, can you see the brown is here and the blues are here? Okay. Now what do you see? Can you see this is just like A minus B and B minus A? Right? What's A minus B divided by B minus A? It's just minus 1. This one is correct. Tangent 30. Right? Because can you see this is just look at this. 2 tangent square A. Look at this. Look at this. 1 minus tangent square A. It's 2 tangent 2A. So tangent 30 again, what is it? Bring down 30, 1 over square root 3, right over left, right? So it's negative 1 plus 1 over square root 3. You should get 3 square root 3 minus 1. Okay? This is for 2.7c. Come again. Okay, from the front, all the way from the front. Okay, so here is okay. Here is okay. Now, you see this is A minus B and this is B minus A. A minus B divided by B minus A will just be negative 1. Yes, because if you think about it, A minus B is like the negative of B minus A, right? Fair to say so. So A minus B over B minus A is the same as negative of B minus A over B minus A. If I cancel, it is just negative 1. So what I'm trying to say is, guys, this is just the minus 1. Okay? Now the right hand side is even better. Is somebody familiar? It's a new friend that you just met. There's a recency effect for this. You think about it, Mitra. This 2 tangent A, 1 minus tangent square A, it should be tangent to A. Look at under page exercise 2.4. Okay, got it? Exercise 2.4. Look at that page number. Question 2.4. You will see. Can So if it helps, what I personally do is I write down all the formula, I paste on my wall. I really paste on my wall and then so you can look at it. Yes. Ask louder a bit, sorry. Oh, I look at the, okay, I always remember smallest angle, smallest figure. You start from 0, 0 is here. This is the smallest thing. 0, 30, 45, 60, 90. Cosine 30, this is here, correct? Where is the left hand side? Left, square root 3 over 2. Square root 3 over 2. Cosine 30. Cosine is number of fingers on the left divided by 2. Sine, number of fingers on the right divided by 2. Yeah. Okay. All good with question 2.7. Then I go to 2.6. Do I go through? Part C. 2.6 part C. Okay, so now let me go through 2.6 part C. Now, if we can, try to keep quiet when I'm going through so that the recording doesn't record your voice. Huh? Okay. Now, tangent 2x, trigo equation, we want to have same trigo variable. So if I see a 2x, I try to apply the double angle formula. This is 2 tangent A, 1 minus tangent square A. Right? Multiplied by tangent x equals 6. Right? So this is a denominator. I just bring it to the right hand side. I have 2 tangent x times tangent x equals to 6. 1 minus tangent square x. So far, okay? Who's actually listening to me for this? Yeah, only Joshua. Okay. So from here, Joshua, you see 2 tangent square x. On the right hand side, 6 minus 6 tangent square x. So far, so good. Simplify this a bit. You have 8 tangent square x equals to 6. Simplify. Divide by 8 on both sides. Tangent square x equals to 6 over 8, which is 3 over 4. So now I have square root. So square root will give me a plus items, right? So now, Joshua, you see tangent x can be plus minus square root 3 over 4. Okay, which basically means that you can have all 4 quadrants. That's how nice it is. And solve this, I hope you can get your 4 answers out. The x will be, what's going on? My Apple Pencil is losing ink. 49, 139.1, 220.9, 319.1. Oh. Okay, look out the formula song. Okay, so next I go to question 2.8. Does 2.8 bother anyone? Not there yet. Oh, 2.8. Which question? Oh, okay, so let's say I start with A. Proving, remember, you make use of all the formulas that you have. So I go to 2.8a. Cosine 90 minus theta. I just need to think of this as A. I think of this as B. Right? So this is the same as cos A, cos B. Remember, cosine is a naughty boy. So sine A, sine B. What is cosine 90? It's basically 0. What is sine 90? Is basically 1. Right? So it's like 0 multiplied by cos theta plus 1 multiplied by sine theta. I'm being naggy here. So that is sine theta. Now I look at 2.8b, right? Naturally, you look at this, right? It's so tempting. I will probably start on the left hand side. Left hand side looks so tempting to do, right? So, but I see that there's a fraction becomes a one-liner. So it means that likelihood here there is going to be a cos A plus sine A that I can cancel off. You see what I'm saying? Because if I'm going to get a one line, right? This will probably be cancelled by the factor. So now in my numerator, right, there's going to be a cos A plus sine A. I take a look at this and I look at this, right? Cos 2A, there are 3. Which one do I use? I'll probably need to get somebody that's a cosine and sine. So what do? Very simple. I go to my cos A plus sine A. Cos 2A over cos A plus sine A. I'm going to think of cos 2A as cos square A minus sine square A, which is cos A plus sine A. Then something square minus something square. Familiar, like, sounds like a square minus b square. So I'm thinking of a minus a plus b. Hey, sorry, wrong. Or a plus b. Yeah, and I think you know how to do it from there. Cancel. So, okay. So yeah, as even though continues, I go to C. Again, I saw a beautiful fraction. I could not control my feelings. I'm going to start from the fraction because the fraction shows so much potential. So just now, Evie was asking, right? When do we use? There are three versions of cosine 2a, right? When do we use which? So now, quick shout out. When there's a 1, you try to choose the identity that allows you to get rid of the 1. What do I mean? Okay, here you'll notice, right? Cos 2a can be cos square a minus sine square. It can be 1 minus 2 sine square. It can be 2 cos square a minus 1. I'm going to choose this and put here because that allows me 1 minus 2 sine square a. And the bottom, I'm going to expand as well. 2 sine a cos a. What do you realize? The 1 is cancelled off. The 2 will be cancelled off. Sine also can cancel off. You are left with minus 2 minus sine a over cos a. What are you supposed to prove? I believe you're trying to prove a tangent a, right? Tangent a. Minus is a plus. So this is tangent a. Okay? And so whenever you are proving and you saw a 1 and a cos 2a coming together, the cos 2a should help you carry on the 1 beside it. This is based on my humble experience. If you caught it, you caught it. If you didn't catch, it's okay. You'll see sometime again in the near future. Now, D. Anyone start at D? D. E. Echo. Elephant. Okay, very quickly, let me just go through D. It won't take me more than 1 minute, right? So 2.8 D. Start from the right hand side. 2 cosecant 2a. This is just 2. Cosecant is sine 2a. Oh, sine 2a. Isn't this 2 sine a cos a? Cancel. I'm left with 1 over sine. Multiply 1 over cosine. Look at the left hand side. This is just cosecant a. Secant a. Beautiful. Proving is an art. You know how to use the universe to your favor. So, like I was saying earlier, that's what I was telling a few of you. Whenever I see a cosine and I see a 1, I'm thinking of changing this. Okay, so which one? In this moment, I just want to say that when I see a fraction, I cannot control myself. I must start from the fraction. Because fraction is always it's easy to operate with the fraction. So look carefully. Don't blink your eyes. For those who are stuck at 2.8e, this is the moment you've been waiting for. Cos x is the same as 2 cos square x over 2 minus 1. Are you okay with this? I'll give you an idea. This is 2a. Think of this as a. Cos 2a is 2 cos square a minus 1. Can or not? It's right. So like I was saying just now, what will happen to the 1? It passes away. Okay. So when you see a 1 and a cosine, the cosine usually allows you to get rid of that number 1. That's the idea. Okay, y'all? Zihan, control your eyes. Don't sleep already, are you? So 1 over cos square x over 2. What's 1 over cosine? It's just secant. And that is 2.8e for you. Okay? When I go through, doesn't mean I assume that you do. I go through so that you be the recording so that you can go and watch. So take your time and complete.